A neutron star or a massive black hole may be the source of mysterious and highly energetic radio pulses that light up skies across the universe. A paper published on Wednesday in Nature describes a particular fast radio burst FRB source. Scientists have spied about 30 FRBs so far, but FRB 121102 is the only signal source that is known to repeat. Its discovery was confirmed in 2014. Located 3 billion light-years away in a dwarf, the burst source packs a mighty punch. It can apparently release 10 million trillion joules of energy in less than a millisecond during a single pulse. Scientists have been racking their brains ever since to figure out what could be powering this unusual event. After analyzing the mysterious output, a team of astrophysicists realized the radio waves were nearly 100% polarized in a given direction. This behavior can be measured by studying the Faraday effect, a phenomenon that occurs when light passes through a magnetic field. Shami Chatterjee, co-author of the paper and a senior research associate at Cornell University in New York, explained to the Register that the observed polarization hints at what processes could be causing the burst. If the emission process was thermal like in an explosion, the emitting particles would be bouncing all over the place and the light would not be polarized, he said. The fact that it is polarized tells us that the emission process must be non-thermal and coherent, like a laser instead of an incandescent bulb. It means that whatever was emitting the energy is in an environment with powerful magnetic fields. Victoria Caspi, co-author of the paper and a professor of physics at McGill University in Quebec, Canada, told the Register, "We don't know the origin of the bursting behavior. We know it must be coming from a very compact region of space, under a few 100 kilometers, because the bursts are so brief. So the source must be compact and the FRB must have traveled through a highly magnetic area, leading scientists to suggest it may be emitted by a neutron star that is near a massive black hole, about 10 to 100 times more massive than the Sun, with a strong magnetic field." Chatterjee also said it could be a neutron star embedded in a very powerful nebula produced when it was born from the death of a very massive star. Or it may be something more exotic. Part of the fun for us is seeing clever theorists come up with different ways of explaining the observations after we challenge them. Another alternative could also be small clumps of matter falling into a black hole, Caspi said. They would have to be truly remarkable clumps given how bright these events are. We really do not understand how the process works. A third possibility is that the signal comes from an advanced alien civilization. The Breakthrough Listen, a project launched to scour the universe for signs of extraterrestrial technology, has identified FRB 121102 as a potential match. Vishal Gujjar, another co-author of the paper and a postdoctoral fellow at the SETI Research Center at the University of California, Berkeley, said we cannot rule out completely the ET hypothesis for the FRBs in general. The team hoped to uncover the exact mechanism and source behind these mysterious bursts in more detail. The biggest challenge to studying them is how short these FRBs last. They appear at unpredictable times in random locations in the sky and are only around for less than a millisecond. Caspi said that it may get easier with the upcoming Canadian Hydrogen Intensity Mapping Experiment CHIME, a new radio telescope capable of monitoring a large proportion of the sky 247 to spot these FRBs. Registered science-sponsored Minds Mastering Machines call for papers now open.